Hello. Okay, so we're back starting with a new section today. This is going to be section 1.2. This deals with graphing quadratic functions when they're in vertex form and also in intercept form. So I'm going to do one example of each. I'm going to try to speed these videos up a little bit. So the first one we're going to deal with today is graphing a quadratic in vertex form. If you remember, a quadratic function is a function that has an exponent of 2. Okay, that highest exponent it's going to have is an exponent of 2. So it can only ever be squared as the highest. So when we're looking at the following example of a vertex form, this is with all the variables in it. It is y equals a times the quantity of x minus h squared plus k. So some things that we can do to kind of break down this vertex form and digest it is we literally get the vertex from something that's in vertex form. That's the whole point of this. It makes it super easy to graph because they literally give the vertex to you in that vertex form. So when you're looking at it, that h and k, okay, h and k is going to be your vertex. So something I want you to be really diligent about checking is within this parenthesis, that h is a subtraction, so it's x minus h, technically therefore being a negative h. You look in vertex form, this is a positive h. So basically what I try to tell all my students is if this is a like x minus 3, then you flip the sign, you take the opposite. If it's a minus something, it becomes positive for your h. If I was adding something on here, I'd take the opposite, and it would be negative in my vertex. And we'll talk about that when we get into the first example. Same thing out here with k. This is a positive k, positive k. So if something was a subtraction of a k out here, I'd have to then go subtract it in my vertex as well. So first thing I get is my vertex. The other thing I can get is my axis of symmetry. That is just literally x equals h. So it's going to be a vertical line on that x along or going through the x-axis. And again, axis of symmetry is that dashed line that goes down the middle of a parabola where I could fold it right over top of that dashed line and the two sides would match up like a little perfect, perfectly symmetrical, therefore the axis of symmetry. We talked about this last time and these two things are still true. If my a, or my number way out in front here, is positive, it opens up like a U-shaped. If my a is negative, it opens down like a hill, I guess I would call that, something like that. Those two things are true of the last section we talked about as well. So let's get into an example. I want you to use all the information I just gave you to graph the function in vertex form. Okay, the function is given. I don't know how well you can see, but this is a negative 1/4. Okay, y equals negative 1/4 times the quantity of x plus 2 squared plus 5. So in the last section we talked about, we wanted to pull out, with our standard form, we wanted to pull out our a, b, and c. So if we come back to the variables we have here, we have a, h, and k. Those are the three that we need to decide what they are. So I want to identify what my a, that doesn't work so hot. I want to identify what my a, h, and k are. Okay, again, I need to do these because those are what find me my vertex and my axis of symmetry, and also whether or not I open up or down. So my a, if we match that back up with the formula for vertex form, you'll see a should always be that very first thing out in front. So the very first thing out in front is a negative 1/4. Remember, we can't forget to bring that sign with it. So this is going to be a equals negative 1/4. H is right there getting subtracted from my x. So now I have an x plus 2. What did we just talk about with h's? If I'm claiming that this h value would be positive 2, I take the opposite of it. My h is actually negative. Okay, so take that opposite. H is actually negative. For K, very last thing being added on, always in the very end. So my K here is 5. It remains a plus 5, okay? We don't take opposite for K. K is usually added on. It's added on here, so it's that positive 5. Once I've done those few things, what I can do is say, okay, well, I know all of my variables, which means I can use those to help me find my vertex. My vertex is super important because it's either the very bottom or the very tippy top. Either way, it's in the center of my parabola. I need to know where is my parabola at. In order to figure that out, the vertex is a really key point in building your entire parabola. So vertex wants to come first. None of my markers want to work. So since I use H comma K to find my vertex will be -2, 5. Okay, and again, I didn't do any math here. I wasn't doing crazy formulas or anything. I truly identified what those variables were within my current equation, and I used what I know about vertex form to find my vertex. I'm gonna do the same thing with my axis of symmetry. I'm gonna call it AOS, because I just don't feel like writing all of that out. Axis of symmetry, that's x equals h. So x equals -2. I'm gonna start getting a graph going here. Okay, as soon as I start finding out some information, I like to start putting it on my graph. It gives me an idea of where I'm at with my graph, how much more I need to find, and just, I don't forget to put anything that I found on there. So vertex is at -2, 5. I go over to -2, up 5. Okay. So another piece of information, my A here, I can see is negative. So when I have a negative A, I know negative A's mean I open down, right? Right here, I open down. So whatever happens from here, I know that from this vertex, I'm gonna have something coming down this way and something coming down that way. So what that tells me is I should probably start finding out information at what happens to the left and right of my vertex. So another thing I can plot on my graph is my axis of symmetry. Again, this is just an x equals line. When it's x equals, that means it's a vertical line because I'm going up and down that entire x equals 2 coordinate. So I'm going to put my axis of symmetry as a dashed line. I got a little wonky there. Okay. I like to do it just a dashed line because it's like my folding line. I can fold it over top of that line and the points all mirror across each other. So after I found my axis of symmetry and my vertex, I have nothing else that I'm given clear cut. There's no other formulas for me to use. So now it becomes an educated guessing game. I need to make an XY table and I make educated guesses. I decide to say, well, I want to know what happens at this point because I think that point's a key part in my graph. So it's educated because when I'm looking at my vertex is at x equals -2, okay? If my vertex is there, does it make a lot of sense for me to say, well, I think I want to know what happens when x is 20, right? That's going to be way over here. Does that matter to me right now? But you should be thinking no, because I have no idea where that could be. I mean, that could be at -500 for all I know, because we are squaring this, so numbers get large pretty rapidly. So I like to maintain my XY table pretty close to my vertex. So you may guess some other ones. The 2 points that I'm going to use is I don't know that I want to go directly to the left and right of that X value, but maybe instead let me try 2 to the right. So that's going to be 0. Now I'm going to choose one side of the graph and I'm going to stay with that side. I went to the right of the graph. So any points I find on the right, I can then mirror to the left. So I'm not going to continue on with my left side. I chose 0, now let's choose 2 over more. You don't have to go by 2s, you can go by a half, you can go by 1, you can go by 4. This is my educated guess. So if I claim an x value, how do I go back and find my y? Well, you plug it into the original equation. So if I'm claiming my x to be 0, I would go back to my original equation of y equals -1/4, and instead of putting an x in here, I go and I put my 0. So it's 0 plus 2 squared plus 5. Now I'm going to do the exact same thing for when x equals 2. I go, instead of putting x in, I put 2 in. Okay, I'm going to let you guys work these out for yourself, and you can kind of do that to your side, to the side of your paper. But if you were to have done so, you should be getting 0, 4, and 2, 1. Oh, that's not at 1/2, that's 1/4. So sorry. Okay, again, you should be getting 4 and 1. For the sake of time, I'm not going to do them up here and work them out. These are now points on my graph. I'm going to go graph 0, 4. So over 0, up 4, and 2, 1, over 2. So what's happening is I'm getting this side of my graph. We talked about this last time. I can mirror those points because I need this side of my graph as well. I went over 2, down 1 to get that second point. So now I'm going to go left 2, down 1. This point was achieved by going over 4, down 4. So I go over 4, down 4. That's one too many. And by mirroring those points, I was able to save myself time because I know they directly reflect across that line, so I don't need to find these points in the XY table again. I can mirror them instead. Okay, so that's my graph of something of a quadratic function in vertex form. Now let's flip over and do one in intercept form instead. Okay. So we've done vertex form. Now we're going to go find something in intercept form. So in order to do that, we need to know a little bit about intercept form. Again, all of these have literally the name in them. For vertex, you get your vertex. For intercept, you get your intercepts. Okay, so the formula for this one is y equals a times the quantity of x minus p times the x minus q quantity. Okay, some characteristics about intercept form is you're able to find intercepts, right? That's what the whole point of this is. So for p, those intercepts are P0. For Q, that intercept is going to happen at Q0. Okay. So we both get an X and Y intercept, or no, both, sorry, not X and Y intercept. We get two different intercepts. If my Y value is 0, okay, that means I'm along my x-axis, right? If we talk about a graph, okay, the reason that these I know our x-intercepts is because my variable is going to be changing, and that's in my x value. In my y value, I have a 0 both times. Okay. So where is y always 0? y will remain 0 across this x-axis always. My x value changes, but if I'm crossing my x-axis, my y value is always, always, always 0, right? We go from like 6 all the way down to 0. This line is 0 and down into my negatives, but that is why I know that those are x-intercepts. So not only do I get my x-intercepts, I also get that axis of symmetry. And that is a little bit more complicated equation. I'm not saying it's complicated, but more than you've probably seen in the past. It's x equals p plus q divided by 2. I don't know if you can tell if that's a q, so I'm going to rewrite it. That's a better q. And again, if a is positive, opens up. If a is negative, it opens down. Okay, those things are remaining true no matter what. Okay, always remaining true there. So we're going to go ahead and try to graph a function in intercept form. So I'm going to move this just a little bit that way again. Instead of vertex form, this is intercept form. And this is no longer my function. My function is actually y equals 2 times x plus 3 times x minus 1. Okay. One thing I want you to keep track of is this time we're both in negatives. Okay, both in negatives. So keep that in mind when we're over here with trying to identify our p's and our q's. So it's going to be like last time where we take the opposite. First thing we want to do, identify p and q. Always, always, always identify what those variables are. And let's go with a as well. So a is easy. It's always that letter or number right out in front. So what's right out in front right now is 2. Now we can identify those p's and q's. P's in the first bracket or first set of parentheses. So that is a 3. But like before, okay, this is a minus p. So just like I take the opposite for h, I also take the opposite for p. So it's not a positive 3, it's a negative 3. Okay? Second set of parentheses is x minus q. Again, it's a minus. So just like h and just like p, for q, I also take the opposite of what I'm seeing. So I'm seeing a negative 1, so that means q is a positive 1. So the 3 things you take opposite are of p, q, and h. Those are the 3 you have to take the opposite of. What do I do with this information? I can find my intercepts. So we come back over here with our formulas for how we find our intercepts. That's going to be taking my p-value and putting it in a coordinate pair with 0, and my q-value and putting it in a coordinate pair with 0. First, let's take -3. Second, let's take 1. These are 2 points that I can graph on my coordinate plane here. Okay, again, these are x-intercepts, so they're on my x-axis. Over at -3, I have an intercept, and over at +1, I have an intercept. Okay? So now what is next? I've found my x-intercepts. I need to now find my vertex. And I apologize. There was one thing I missed in telling you, is that not only is this my axis of symmetry, I can also use it to find my vertex. I'm so sorry. I meant to put that part in there. I didn't want to confuse you, but I meant to put it in there. How do I use that to find my vertex? Well, we know the axis of symmetry goes through our vertex. So you are always essentially using the same method to find it. So I'm going to start off by finding my x coordinate of my vertex. I do that by taking x equals p plus q over 2. So what this will look like for me is I need to take P, -3, plus Q, which is 1, and divide it by 2. I'm getting here that X equals, take -3 and add it to 1, that's -2, divide it by 2. -2 divided by 2 is -1. So I'm claiming that my X value in my vertex is -1. What do I do when I have an X value and I want to find the corresponding Y value for that coordinate? We plug it in, right? So I have to use what I know, plug it into what I've been given, instead of having X's. So now, be very careful. I have 2 X's in my original equation. I have 1 and then 2. For both of those, I plug in -1. So 2 times -1 plus 3 times -1 minus 1, okay? I don't know how well you can see that. So again, I don't want to take up all of your time in trying to work this out for you. If you do so, you should get to the value that X equals -8, meaning that I put this -1 and -8 together in a coordinate pair, and that should be my vertex. So I go over -1 down to -8. Connect my lines. My A was positive, so I should have opened up, right? That's exactly what I did. Okay, that's all for this video. Thank you very much. I'm awful at trying to figure out how to end these. Okay, I got it. Bye.